Hey, College Math, here is 1.2. Let's go ahead and take a look at random sampling in this section. Our objectives are to define different sampling methods that we have available to us and describe situations in which sampling methods are used. Okay, so in the previous section 1.1, we talked a lot about the basics of a statistical study. We have the three main parts. We have the variable that we care about, the population, and the sample that we grab, right? And we talked about briefly how the reason we take a sample is because the population, we want to study the entire population and make claims about it. But a lot of the times the population is impractically big, right? Think kind of the census is kind of one idea of wanting to study the entire population of the United States, right? But let's think about the things that come with it, right? There's a reason why the census is only done every 10 years, right? Every 10 years. And you don't really need to write this down. I'm just kind of giving you an example of one way that studying an entire population is impractical, right? And so they only do this every 10 years because of the fact that there's a lot of people solely in the United States. And so we have things like doing it every 10 years and then having to kind of take the time and hiring a lot of people to go around and kind of collect that information from each household. And so in other cases where it's not as important as a census, we take a sample, okay? And we actually take what's called a representative sample, okay? So instead of looking at the entire population, we're going to take a representative sample instead. Okay, so what does it mean for a sample to be representative? Well, it's a sample whose characteristics are the same or very similar to that of the population. Okay, so your sample needs to if we want to be able to use this sample to make claims about the entire population, I can't just pick whatever I want because then that's biased. And we'll talk a lot about bias in 1.3 next week. But if I want to be able to take this sample, do stuff with the sample, and then make conclusions about the entire population, the characteristics of my sample better be pretty much the same, or at least really close to the whole population, right? And so there's a couple different ways, there's a couple different ways we can take a sample. We have 5 different methods that we'll look at in this class. There's a lot more, but we're going to focus on these 5 for this class. Okay, so we have simple random sampling is our first one. Okay, and that's kind of the most basic one. Every object individual has the same chance of being chosen for the sample. Okay, so what does that mean? There's a lot of ways to kind of think about this. We can think of a random number generator. Okay, and that's kind of the main way that we can see simple random sampling happening. Every single, let's say we're doing a study on high school students, I would assign every single high school student a number, 1 through however many there are. And then I would put it in like a program like Excel or any other program that would randomly just pick one of those numbers, okay? Every number has equal chance of being chosen. And so that is kind of simple random sampling at the heart. A more smaller way of thinking about it is, drawing names out of a hat. So drawing names out of a hat, right? Because you put, a bunch of names in a hat or a bucket or whatever kind of container, and you shuffle through all the papers and then pull one out. That's another way to think of simple random sampling. Just kind of every single person or every single object has the same chance of being chosen, okay? The next idea or the next type of sampling is stratified sampling. Okay, so what we do in stratified sampling is we divide the population up into groups, and we're going to call those groups strata. And then we're going to take a random sample from each strata. Okay, so going back to the high school student example, one way I could divide my high school up is by grade, 9th, 10th, 11th, 12th. So I can say the grade level is my strata, and then I'm going to take a random sample from each strata. Let's say I take 50 random freshmen, 100 random sophomores, 20 random juniors, and then 50 random seniors, okay? That's one way of doing stratified sampling, dividing it up and then sampling from each group, okay? I'm sampling from each group, okay? I'm not gonna leave any group out, okay? So that each is important. you're going to sample from every single one, not just 9 of the groups out of the 10 or 3 out of the 4 groups, every single one. Okay, that's going to be important when we talk about the difference between that and cluster sampling. But let's talk about systematic first. Systematic sampling, we're going to line up all objects and individuals and then choose every kth individual, where k is some whole number. What that right there means is, like, think about, I'm choosing every 4th individual, or every 7th individual, or every 100th individual, right? So back to the high school example, let's say I line up the entire student body. And what I'm doing is I'm going to go through and I'm going to choose every, say, 10th student. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, you're in my sample. Start over. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, you're in my sample, et cetera, right? Until you get pretty much whatever amount you need in your sample. Okay. Now let's look at cluster sampling. Okay, so in cluster sampling, we have the same start as stratified sampling. We're dividing the population up into groups. Then we're going to randomly choose some groups and survey everybody in those groups that we choose. Okay, so if I think about how in this one we talked about separating the high school students up into grade level, instead of sampling from all grade levels, from all 4 grade levels, what I want to do is instead, maybe let's say I choose only freshmen and seniors. And then when I choose those 2 groups, I'm going to survey every single freshman and senior. I'm not going to choose an amount of freshmen and seniors to survey. I'm going to survey every single one of them. And I'm going to ignore the sophomores and juniors. Okay, that's the difference between cluster sampling and stratified sampling. And we can kind of draw a little picture here to help you. Draw a little picture. I'm going to do it up here to help you kind of understand that. So let's say this black box is my entire population. Okay, and let's say that I divide up into these groups right here. So these blue lines are showing my groups. So I have 1, 2, 3, 4, 5, 6 different strata, or 6 different groups. In stratified sampling, my sample is coming from every single one of the groups. Okay, and so the red circles here are my sample. I'm choosing the sample from every, I almost called this, oops, I went all the way down. There we go. I almost called this systematic. Stratified. Okay, in stratified, I'm surveying from every single group. In cluster, okay, if I do the same exact thing, I have the same population, the same 6 groups, right? In cluster, what I'm going to do is I'm going to choose, let's say, and the amount of groups that you choose is also random, determined by whoever's doing the sample. You just obviously wouldn't choose every single group, right? Because then you're choosing the entire population, and that wouldn't help. So let's say that I'm choosing 3 of the groups, okay? So let's say I choose these 3 groups. Well, then my sample is going to be those entire groups. Okay. And so that would be cluster. If you're kind of a little bit, hopefully, if you're a little bit more of a visual learner, this visual helps a little bit, okay? To understand the difference between these two, because they really do, if you read through the definition, they're really similar sounding, okay? And I don't want you to confuse them when you're doing your practices or when you see a question about this stuff on the checkpoint, okay? And then the last sampling method is convenience sampling. Choose whoever and whatever you want. Convenience sampling is kind of like the lazy, or sometimes it's the only way we can do it. Maybe we don't have access to information. You know, for example, if I wanted to divide everybody into freshman, sophomore, junior, senior, maybe I don't have access to that information. And maybe it's just too hard for me to do that as one person. And if you're doing it as a student, even harder. It would take you a while to maybe get access to that kind of information if they do allow you, right? So convenience sampling, one way to convenience sample is you stand out in front of the high school, and as students are walking in, you just ask whoever you happen to ask. Okay, whatever your survey question is, you ask whoever has time to stop by. You know, you always have those people that stand out in front of grocery stores asking questions, or, you know, I remember when I was in college, there was always people standing kind of in the walkway, you know, stopping whoever had the time to ask survey questions or to sign petitions and all that stuff, right? So convenience sampling really is just do it however you are able to, as long as you get a sample, okay? And the thing about convenience sampling, we talked about representative sample up here. Convenience sampling hardly ever gives us a representative sample, okay? So hardly ever gives representative sample. Okay, the idea about doing these sampling methods is to get a sample that is hopefully representative of the population. Convenience sampling, hardly ever. Maybe depending on the characteristics of the population versus the people you ask, you might luck out and get the same characteristics, but it's not really, the guarantee is very small versus these other sampling methods, okay? All right, let's go ahead. We only have one example for these notes because if you haven't already noticed, there's a lot of writing, right? So we're just gonna keep it to one example. We're going to identify the sampling method being used in each of these situations, and we're going to give a short justification, okay? And by short justification, I really do mean short. You don't need to write multiple sentences. Just tell me it's this sampling method because of this, right? Let's go through and look at that. Part A, a researcher wants to determine the different species of trees that are in the Coconino National Forest. She divides the forest using a grid system, then randomly picks 20 different grid sections and records the species of tree in each section, okay? So let's think about what's happening here. We're dividing up the trees into a system, okay? A grid system. So you can think about, I don't know, like here's our forest, okay? Here's the Coconino National Forest. And what this researcher is doing is she's dividing up into grids, okay? Well, hopefully this kind of reminds you of the picture we drew up there, right? Where we divide up into different groups. In this case, these are our strata. Each of these little squares is one of the strata, one of the groups. She's choosing 20 of those grid sections and recording the species of tree in each section, okay? So the fact that they're telling us that she's choosing 20 of them and not all of them, that right there, that distinction already tells us that this is cluster sampling because she's not choosing all sections. She's choosing a certain amount and then recording the species of tree, all of the trees in those sections, okay? So this is cluster. Okay, because choosing only some sections and surveying all trees in those sections, okay? All right, it would be systematic if she went into every single section, every single grid square and surveyed some of the trees in those squares, okay? B, a pollster stands in front of the organic foods grocery store and asks people leaving the store how concerned they are about pesticides in their food. Okay, we kind of talked about this at the very end of the definitions up there. This is convenience, okay? Surveying. And the reason why is because this pollster is only surveying those people that pass by. Only those that pass by. Okay, convenience sampling for that one. C, the Pew Research Center wants to determine the education level of mothers. They ask a random selection of mothers from their database about how much education they've completed. Okay, so let's think about this one. There's really not much details. They're not telling us that they're dividing the mothers into groups. It's definitely not convenience because they're not standing out somewhere kind of surveying the mothers as they come and go. They have a database of these mothers and they're just randomly selecting every single one to include in their sample. Okay, so the lack of kind of details here and the fact that it's just a random selection of mothers from their database, this one tells us that it's those details tell us that this is a simple random sample, okay, in SRS. All right, completely random selection, okay? And that's pretty much the key to telling you that this is a simple random sample. It's completely random. Of course, they don't tell us how they did it. They don't tell us that they did it with a random number generator or if they just put a bunch of names of these mothers in a hat. But we can kind of infer from the fact that it's just a random selection. They don't have any other details to share with us that this is a simple random sample, okay? D, Penn State wants to determine the salaries of their graduates in the majors of agricultural sciences. business, engineering, and education. They randomly select 50 grads from agricultural sciences, 100 from business, 200 from engineering, and 75 from education to survey. Okay, so we have this idea of dividing up into majors. Okay, we divide it into those 5, or sorry, I can't count, those 4 majors. And notice that they're surveying some of those graduates from all of those 4 majors. Okay, so since they're taking pieces from every single major, this is stratified. Okay, and it's because they're serving some grads from all 4 majors. Okay, there's obviously more majors than just this, but because this says that Penn State only cares about agricultural sciences, business, engineering, and education, those are the only 4 groups that we care about. Yes, there are more majors than just that, but these are the only ones that Penn State cares about. And so because they're serving from all 4, this is stratified. Okay, they're not taking every single graduate from those from a few of those majors. They're choosing some from all. Okay. And then the last one, we can kind of already guess what this one is, but let's read through it. In order for the Ford Motor Company to ensure quality of their cars, they test every 130th car coming from the assembly line at each of their manufacturers. Okay, they're testing every 130th. Okay, so that automatically tells us that it is a systematic sample. Okay, surveying every 130th car. Okay, and you see systematic sampling a lot when it comes to assembly line work, like cars, computer parts, other stuff like that, where there's a lot of stuff that they're producing. So instead of checking every single object coming off the assembly line, they choose every so often, or every other whatever increment they're going in, right? Okay, so those are the 5 sampling methods that we're looking at for this section. Okay, we're going to talk a lot about bias in the next section when we come across that next week. But for now, let's kind of recap a little bit about the sampling methods. The idea is that we want to take these samples so that they're representative of the population. We have 4 sampling methods that work for us really well. And then the one convenience that hardly ever works, but sometimes that's the only thing you can't do. Okay. All right. Hopefully this sounds good, everyone. Ask your questions in class, and I will see you in the next one. All right. Have a good rest of your day.